For the strong acid, strong base titration from the last video, I used HCl, hydrochloric acid, for my strong acid. The concentration was 0.1 molar. The strong base I used was sodium hydroxide, NaOH. I did not know the concentration of the base. The purpose of this calculation is to standardize the base solution. When you standardize a solution, you determine the exact concentration of that solution. So I began the titration by filling both the acid and base burette all the way to 0. So the initial burette reading was 0. When I had finished the titration by reaching the appropriate pink endpoint, I had dispensed 24.98 milliliters of the acid and 24.91 milliliters of the base. Using the volumes of acid and base, the concentration of the known acid, and a mole ratio from a balanced chemical equation, we can determine the molarity of the base. So this is just another calculation that we have to do involving stoichiometry. So we're going to start with the volume of acid, 24.98 milliliters. I'm going to convert that to liters. You will see all of my numbers will have a unit in a label. I can then use the concentration of the acid to convert the volume of HCl to moles of HCl, because a concentration, a molarity, means moles per liter. So my liters will cancel, and I am now in moles of HCl. Well, I don't want moles of HCl. I want moles per liter of NaOH. So how can I convert from moles of HCl to moles of NaOH? What will go next? That's right, the mole ratio. We need a balanced chemical equation to know what the mole ratio between HCl and NaOH is. So this is an acid and a base reacting together. So we should remember that an acid plus a base produces water and a salt. So let's figure out what salt is going to form. HCl will break up into H plus and Cl minus ions. NaOH will break up into Na plus and OH minus ions. We know H plus and OH minus are going to form water. Our salt will be the cation from the base, Na plus, and the anion from the acid, Cl minus. They're going to form NaCl. Remember, we also get energy. When we balance an acid-base neutralization reaction, we assault it. We start with a 1 in front of the salt. We will see then that we need 1 sodium hydroxide and 1 HCl. Also need 1 water. So the ratio is a nice 1 to 1 to 1 ratio. So between the acid, HCl, and the base, NaOH, the mole ratio is simply 1 to 1. 1 mole of HCl gives me 1 mole of NaOH. This will cancel my moles of HCl, and I have moles of NaOH. I'm only a step away. I need moles per liter of NaOH. Well, I know I used 24.91 milliliters. So all I have to do is divide by the volume of base that I used. Converted to liters, that's 0.02491 liters of NaOH. Once I calculate this, I will have the concentration of my unknown NaOH. I will have standardized it. When you run this calculation through your calculator, you will get 0.10 molar NaOH, which is exactly what the concentration of the NaOH was. You can only have 2 sig figs in these calculations because we are going to be limited by the molarity of the acid, which only has 2 sig figs. The lab practical will look just like this. You are going to use sulfuric acid to do the titration. You will be determining the molarity of an unknown NaOH solution, just like I did here in the lab. So the balanced equation for sulfuric acid and NaOH is a little different. So let's try this one out. Acid plus base makes water and a salt. Let's figure out what the salt would be. Sulfuric acid will break up into H plus and SO4 2 minus. NaOH is once again Na plus and OH minus. We know the H plus and OH minus form the water. The salt will be formed from Na plus and SO4 2 minus. So I will need 2 of the Na pluses to balance the 2 minus charge on SO4. So the formula would be Na2SO4. And of course we get energy. To balance this, we salt it. We put a 1 in front of the salt. That will mean we need 2 sodiums. So on the reactant side, we need 2 NaOHs. We only need 1 sulfate ion, so we only need 1 H2SO4. When we balance the waters, we see we need 2 water molecules. So this ratio is going to be a little different. In my sample that I did for you, it was a nice 1-to-1 ratio between acid and base. Well, now it's going to be a 1-to-2 ratio. 1 mole of acid requires 2 moles of base. So keep that in mind in your calculation. Now you are going to know the H2SO4 concentration initially is 0.10 molar. You are going to figure out the concentration of the NaOH. We don't know that. The calculation will set up just like before. You're going to want to start with the volume of acid, and then you're going to use the molarity of that acid to convert to moles of acid. So I'm just using hashtags where you're going to put your volume readings, because your volumes can have 4 sig figs. The mole ratio will be 1 mole of acid to 2 moles of base. And then you simply need to divide by the volume of the base, which will be 4 sig figs. That's why I have 4 hashtags there. So this is the setup for your calculation when you do the practice titration and on the practical. You just need to fill in the volumes and determine the concentration of the base. Good luck to you.